Thank you. Good afternoon and good evening. My name is Lucy from Kenya. I'm going to discuss with us in this session traditional breeding in comparison to genetically modified organisms in the direction of food security. Which alternative is more safer? In this discussion, I shared with my teammate Mohamed Tasiu from Nigeria. So in introduction, we are pleased to be in this debate. We welcome you to this debate, dear esteemed panel and fellow debaters. Please welcome and let us journey together in this discussion. We are discussing a critical issue in global health, prioritizing traditional breeding over GMOs, as we seek for healthier security and sustainable development in terms of food security. And we are looking at traditional breeding as a process where crops and even livestock are bred through a selective process of crossing animals and plants with other plants or animals of desirable traits to produce offspring that show improved characteristics. And the kind of improved characteristics that we are always looking for is in terms of productivity, in terms of resilience, in terms of disease and pest tolerance. And we are also looking for the ability of this offspring to continue reproducing even into the future generations. So unlike when we look at GMO that looks at genetic tools that bring in new genes into varieties to be able to produce a new offspring, traditional breeding relies on natural processes, and that is why we are saying that traditional breeding is more safer because it's more natural and inclined to the natural environment that these crops are being bred. So our team affirms that traditional breeding is proven, it is safe and sustainable, and it contributes to improving crop yields and resilience, and ultimately gives us better human health. Unlike GMOs, traditional breeding preserves the natural genetic diversity of plants and animals, ensures food safety, and supports small-scale farmers like those who are found in the sub-Saharan Africa and also the global south. We look at the constructive arguments. As proponents of traditional breeding, we are saying that traditional breeding is safe and has very, very few risks because it relies on natural processes, it minimizes unintended consequences, and ensures food security, according to a study that was done by Cuba et al. In 2001. GM food is capable of affecting the transfer of antibiotic-resistant genes to humans, and this makes the human population sometimes to become resistant to ordinarily used antibiotics, resulting to inability to treat ailments with antibiotic drugs. And most of the people that are affected are people in the sub-Saharan Africa, poor households. You find that these people end up suffering because the drugs that they would ordinarily use, they can no longer use because of antibiotic-resistant genes that they have obtained from consuming genetically modified foods. And also reports of toxicity and allergenicity have been reported as a risk factor associated with genetically modified organisms. We are also looking at the environmental sustainability. Traditional breeding promotes agrobiodiversity, enhances ecosystem services, and resilience to climate change impacts. A study that I've not quoted here actually narrates like there's a year in which traditional breeding had actually achieved 143 lines of maize, while genetic engineering was targeting to achieve only 2. And this is because of the environmental sustainability. You find that traditional breeding is able to achieve faster. We are able to achieve climate resilience. We are able to maintain our ecosystem services while coming up with new breeds. And this one ensures that we have environmental sustainability. We have plants that have been genetically engineered to have a herbicide tolerance in them. And because of this, you find that for farmers to efficiently farm these varieties, they have to use herbicides. And these herbicides come to disrupt ecosystem services by eliminating beneficial pests. And this causes environmental unsustainability. And traditional breeding has been proven to ensure that. We are also looking at poor resource farmers. Are these farmers able to access these genetically modified organisms? No. And are these farmers able to access traditionally bred varieties? Yes, because these varieties are locally available, they are accessible, they can get them from their neighbor farmers, and they are able to access them year in, year out. But access to genetically modified organisms sometimes has a cost impact, and some of these indigenous people in low-income households cannot afford that year in, year out. We are also looking at consumer choice. A study was carried out some years back in 2011, 2012, where in America they had grown some rice that was genetically modified for herbicide tolerance. And when the market realized that this rice had actually been engineered for this kind of tolerance, the market rejected, and it caused a lot of losses for the American producer. So you find that that kind of rejection is not found anywhere in traditionally bred produce. We don't see it in maize, we don't see it in rice, we don't see it in wheat. But when we introduce a genetically modified food, sometimes you find that farmers tend to shy away. And we are not just saying that it is only in crops. No, we are also saying that it is animals. For example, here in Kenya, most people want to consume goat meat from traditional bred goats, even for sheep. And when you bring in the idea of improved sheep or improved goat, you find that they are adopting them because of something like only milk. But for the meat, people are more receptive when the meat is coming from a traditional breed and not a genetically modified breed. We are also looking at preservation of medicinal properties of traditional plant materials. The former generations of our fathers, our grandparents relied on the ecosystem. In terms of the insects, they relied on traditional plants, wild plants, some of them cultivated for their medicine. They did not go for this advanced medicine that we find in chemists. Most of them relied on the ecosystem available resources for their medicine. And when traditional breeding is taking place, we have ecosystem players like pollinators. They take something from here and bring it here, and you find that traditionally bred plants have carried in them these medicinal properties for many generations. But when we look at genetically modified organisms, we are not able to categorically and empirically say that we are transferring medicinal properties during our genetic engineering, unless we have specific studies that are targeting these genes to transfer them to new breeds. But we haven't really seen that empirical example in terms of bringing around traditional medicinal properties of these traditionally bred plants and animals. Like here in Kenya, we believe that goats that feed on herbs, they are out there in the world. Their meat their meat actually carries some medicinal properties, unlike the new breeds that we are importing in that have genetic modifications. Those ones, the people don't believe that they actually carry medicinal properties in their meat. We're also looking at climate change, resilience, and adaptability. Traditional breeding has been proven time and again to be able to come up with new lines of breeds that show a lot of climate resilience. They have been bred in that climate. As the climate was changing, the crop was also evolving in that climate. So these crops tend to show resilience faster and easier than the ones that we are breeding through genetic engineering. And these plants that have been bred with genetic engineering, most of them want to be irrigated, most of them want to be maintained through systems that cause climate and adaptability. And here we want our farmers, our smallholder farmers, people who rely on the climate factors to be able to farm. We want them to be able to farm. We want them to be able to put food on the table. So if we come up with breeds that must require certain climatic conditions, like if we have depressed rains, we must irrigate, then we leave out farmers who are not able to do that. And traditional breeding has not brought us to a place where we must irrigate for us to have food. No, we might have depressed yields, but these breeds, traditionally bred breeds, eventually give us yields, and so we ensure that our farmers continue to have food on their tables. We have heard what our opponents have said, and we hear their discussion, we hear what they are saying, but we still stand to say that even though genetic engineering claims that there's enhanced productivity and food security, and that it can significantly increase crop yields and reduce losses, that story tends to change. First, with climate change, traditional methods have been proven to allow for selection of complex traits like drought tolerance and yield increase or yield stability. And these are controlled by a complex of many genes that are traditionally passed from mother to offspring during traditionally breeding. Conventional breeding allows for high-yielding varieties. We have had these ones coming up, like high-yielding varieties of wheat and rice that have fundamentally changed global agriculture to ensure that we have food security. Climate resilience, like I said earlier, we have had many varieties come up in traditional breeding compared to genetically modified offspring. Traditional breeding has given us more varieties in terms of climate resilience compared to genetic engineer. This has been shown in a study that was carried out by Natasha Gilbert in the year 2014 in a Nature journal. We also have opponents of traditional breeding saying that GMO reduces chemical use. This is really contrary to the practice that we see happening in many production systems. Genetically modified crops actually require use of herbicides, they require use of pesticides for you to be able to sustainably produce these crops. And even to sustainably keep these animals, the environment has to be hybrid. The environment has to be hybrid. And this has been seen in various studies, both in the crop sector and in the livestock sector. The scientific advancement that brings in precision. For example, in the flower industry, we find that people bring in new genes to bring in color for the excitement of the consumers of flowers. But we find that when we come to crops, the food that we eat, yes, we have seen this rice that has been engineered to take care of vitamin A, but we find that we are only precisely bringing in one attribute. Unlike the traditional breeding that carries a concoction of many attributes with it, precision in GMO only brings one. But what does the farmer want? What does the consumer want? What do we want as a population when we look at food security? We want the whole thing. So precision is good, but it is not giving us the whole thing that we actually need for our well-being. And economic opportunities, of course, yeah, that comes up with genetically modified organisms produced in large scales of land, and we have the opportunity of having high returns on our investment. But now we are looking at monocropping. And that is not the picture that we are picking from our farmers. That is not the picture that we are picking from our rural households. Our rural households are not looking at monocropping. They are looking at everything being put together. They are looking at growing maize and beans. They are looking at putting their vegetables in those gardens. So when we are growing maize that is herbicide tolerant, and we have to bring in a herbicide to be able to farm, and this herbicide sometimes, even when you don't bring in a herbicide, the herbicide tolerance exudes hormones that kills the other crops around this maize. So you find that we cannot have the whole idea of a mixed cropping system when we are using genetically modified organisms. And we don't see that in traditional breeding. Traditional breeding allows the farmer to have a mixed cropping system in their small tracts of land. And we find that this becomes more sustainable. And like when we are looking at GMOs that require monocropping system for sustainability. In our closing statement, we really want to emphasize, we want to plead that we actually consider traditional breeding because it aligns with the sustainable development goals for a sustainable agriculture, for a sustainable future, and to ensure that we actually achieve food security. Let us build a future where traditional breeding and innovation converge for a greater good. Let us also strive to build a future where our native species of food and livestock will still serve generations to come. Let Africa and the global south be proud of our native species that we have preserved, have been preserved by our fathers and our grandfathers for many generations. Let us be proud of them and let us also preserve them for the coming generations. And let us crown the efforts of our forefathers by keeping what we have received for the future. Let Africa honor her story of our native seed system. Let the global south own their story of their native seed systems with pride and confidence, for in this shall the future generations pride in and nourish itself. Thank you very much. We have a list of references that we have checked with, and we welcome questions and answers. Thank you very much for listening.